All right, all yours.
Okay, in my training session, I will introduce reaction data and data processing, which will include the following three parts. The first step is to how to collect the reaction data. The second part is about data processing. And the last part is how to convert the raw data to the model readable data. And here is the question I'm trying to answer. And in the first step is when we talk about the reaction data, there's one general question is where does the data come from? And here the following reaction is backward heart rate animation reaction, which is a classic reaction. And here is a reaction, for example. So once we have the reactions, how can we collect the reaction data from the reaction? And here I showed a general ways graphic user interface, which has a lot of boxes, which we can type in all the reaction information, including its reaction ID, temperature, reaction type, and also in the creation date and time. And all the reaction components should be added. Reaction should be added, including its name, compound ID, and the small string can be given automatically from its LPC name. And after all the reactants have been added, then we can add the product, including its LPC name, yield, compound ID. And also there is some comments can be typed in, like a description for the reactions. And after all the reactions have been added, then we can add one reaction. And after one reaction has been added, then we can start to build another reaction. And after all reactions have been added, then we can get the reaction data, which including all the reaction information for all reactions we have typed in. And once we have a data like that, the next step we do is to process the data. And here I want to use the AstraZeneca data set as an example to talk about how to process the data. And the AstraZeneca data set is an XML format file, which have a quite similar data structure with the JSON format files we showed here. But the data type is different. So we need to use the script I showed here to convert the XML format data to the dictionary type or the JSON type data. And after the data has been converted, then we need to understand its data structure. And for some of the data sets, here is the data structure included in the data files. But for some of them didn't have the data structure, we need to zoom into different keys and to check if there are subkeys under the key. So after we know its data structure, the next thing we do is to build a column including all the reaction components we needed. And here is a script which shows general ways you can do to guide the values you needed. And there is usually two types of data in the JSON data. So one type is dictionary type, which means you can directly get the values from under the key. And there is a second type is a list data, which you need to load all the items under the list and get the values from the keys. And once you have a column including all the reaction components, the next thing you do is to convert the compound name to the small strings. And in the AstraZeneca dataset, there is a more structure, also known as the SDF files, included, which can be used to generate the small strings. And here is the two ways you can do that. So first is to generate the small strings from the SDF files from the compound database. And for the compounds which has no small strings, its compound name can be used and based on the pump compile Python package to get the rest of the small strings. And after all the smells have been generated, then for the AstraZeneca dataset, there is no classification between the alkylate and amines and also the ligand base. So the next step is to classify all the reaction components. So here I use the pump compile compound package to read all the molecule information, item information, which can be used to do the classification. And after reaction component being classified, the next step is to do general data cleaning. I found in the data set that there are a lot of temperature has initial values, which means it's negative 273 degrees Celsius, which should be modified based on the comments. And after the temperatures been modified, then the next step is to remove the empty entries, which some of them didn't have the reaction components. And the last part is to remove duplicate values, which can raise problems for the prediction. And here comes the last step. So once we have smell strings for all the reaction components, and the next step is to calculate the chemical features and build to a feature vectors. And for the DFT calculation, I use Gaussian's software. And so first, I generated the XYZ coordinates from the smell strings, and then to write Gaussian input files and do the DFT calculations and calculate all the chemical features, both for the molecules and also for the atoms. And for the molecule features, it can be put in under the molecules. But for the atom features, the atoms should be looped, and all the atom feature can be input in under the different items. And after the chemical feature vector has been built, then we can start to build a molecule graph, which can be used to do the prediction based on the machine learning model. And that's all for my presentation part.